Hello students, today we will study the question number 4. We will continue the exercise 6.3. This is the exercise of standard 10 chapter number 6 triangles. So what is the question? Question is, here we have given one of the figure QR upon QS is equals to QT upon PR and angle 1 is equals to angle 2. So that triangle PQS is similar to triangle TQR. So here one of the diagram we have given like this. Two triangles are there, PQS and TQR. These two triangles we have to show that both are similar to each other. Conditions we have given is QR upon QS is equals to QT upon PR, and angle 1 and angle 2 we have given that both the angles are equal. So we have the three criteria to prove the two triangles similar: angle, side, and side, angle, side. So let us see which criteria here we can use. Okay, so first of all, notice this thing. Here we have given that QR upon QS is equals to QT upon PR. If we have given here that QT upon QP, then we can use the theorem number 6.2. Okay, so how we can use that? See, we have to replace this PR with PQ. How we can replace it? So that we have given one of the condition here that angle 1 is equals to angle 2. Now see, angle 1 and angle 2 both are of the triangle PQR. So here we have to start with, in triangle PQR, angle 1 is equals to angle 2, right? If the two angles of a triangle are equal, then their opposite sides are also equal. So that therefore we can write down that opposite side of angle 1 is PR, and opposite side of angle 2 is PQ, right? So this how we can write down? Now you can write down the reason that sides opposite to the equal angles are equal. Okay, now instead of this PR we can put this PQ, right? So this is the same thing we have to write down here, that QR upon QS is equals to QT upon, instead of PR now we are putting PQ. Now see, this is the ratio of the QR to QS and QT to QP or PQ. That means now think about the theorem number 6.2. In theorem number 6.2, if we have given that the one of the line PS divide the two sides of the triangle such that this ratio is there, then we can say that this line joining these 2 points, here it is PS, will be parallel to TR. So here this is the ratio, and we can write down that P and S are the points on sides QT and QR of triangle TQR. So two sides of the triangle is divided into the two parts and they are in the same proportion. So the third side will remain, that is TR this third side TR will be parallel to PS, right? If we join these 2 points, PS is a line and it will be parallel to TR. So here we can write down that PS is parallel to TR, right, according to the theorem number 6.2. So here, as PR and PS and TR are parallel, so we can write down that this angle QPS will be equal to angle QTR TR. Why? This is, we can write down according to the corresponding angle theorem, right? Two lines are parallel, PQT is the transversal, so this angle and this angle will be equal to one another. In the same way, here also we can write down that this angle and this whole angle will also be equal. So this angle is PSQ. Here also we can write down that angle PSQ will be equal to angle TRQ. TRQ. So in this two triangle that we have to prove both are similar, PQS and TQR. Two angles are equal to one another. Okay, angle Q is the common in both the triangle. So angle Q we can write down as angle PQS. Angle PQS is equals to angle TQR. TQR. These two angles are common in both the triangle. These two angles we can prove here according to the corresponding angle. So all the three angles in both the triangle are similar to each other. Now what will happen? We can write down that both the angles are similar to each other. Triangle PQS is similar to triangle TQR according to the angle criteria or angle rule. So see what we have given, what we use, how we use that thing, whatever we have given, and how we can prove this similarity of the two triangles. Okay. Now let us study the question number 6. Here we have given that one of the diagram we have given, if triangle ABE is congruent to triangle ACD, so that triangle ADE is similar to triangle ABC. So these things we have given that ABE is congruent to ACD, and these two triangles we have to prove that are similar. So the triangle we have given the congruent are ABE, this triangle, and ACD. These two triangles we have given congruent. ADE, this smaller triangle, and ABE, this bigger triangle. We have to prove that both the triangles are similar. So one thing here we can notice that in both the triangles, angle A is common. Yes, angle A is common in both the triangles. Okay. Now we have the three criteria: angle, and side, and side angle, side. Out of these three criteria, we have to use one of the criteria. Out of that, angle is we have. So now two criteria are remaining. Side we cannot use here because angle is there. So either angle or side angle side criteria we can use here. So let us see what we can do further. We have given that triangle ABE is congruent to triangle ACD. So let's start from that. Triangle ABE is congruent to triangle ACD. Now we know that if the two triangles are congruent, their corresponding parts are equal. So AB side will be equal to AC side. AB is equals to AC, right? AB side will become equal to AC side. In the same way, AE side will become equal to AD side, right? AE side will become equal to AD side, right? Now we can write down these two things according to the CPCT, corresponding parts of congruent triangle, right? This we can write down according to the CPCT. Now what we can do here, see, ADE is the smaller triangle and ABC is the greater triangle. So if we divide this equation with this equation, what will happen? See, we can do one thing here. This divided by this, we can take left hand side divided with the left hand side, and right hand side will divided with the right hand side. So here, okay, we can do also one more thing here, that AB upon AC we can take, and what will happen? It will become 1. In the same way, here also if we do AE upon AD, then again it will become 1. So now we can compare both these equations because both have the right hand side equal. So when we compare both these, we get here AB upon AC is equals to AE upon AD. Right? Now cross multiplication. We can take this AE to the here and AC to here, right hand side. So we can write down that AB upon AE is equals to AC upon AD. See, right? So this thing we can apply by taking this AC to the left hand side and by making both the right hand side equal, and then we compare. Okay, we can do this thing right directly by dividing this equation with this equation. Left hand side will divided with the left hand side and right hand side will divided with the right hand side. So also we get the same thing, AB upon AE is equals to AC upon AD. Or we can do this method also, right? This will be easy for you to understand. Okay, now see, AB is the smaller side angle, AB is the smaller side, greater side, and AD. Okay, what we require here is AD we have to require in the denominator of the AE. So, okay, now see both this value AE and AD are equal. AE and AD both are equal, so we can interchange both the values. So also we can write down that AB upon AD is equals to AC upon AE, right? Yes, we can write down because both the values are here equal. So instead of AE we can write down AD, instead of AD we can write down AE. Okay, so now see, AB upon AD, bigger side upon smaller side is equal to bigger side upon smaller side. So this is the ratio of the two sides of the triangle and they are equal to each other. Also one of the thing we have given is that angle A is common. So angle BAE is equals to angle BAC. So in two triangles, one of the angle and equal and two sides are in the same proportion. So by side angle side criteria, we can write down that triangle ADE is similar to triangle ABC, right? So here we which criteria we use? Side angle side criteria. So in this way we can solve this type of problems and we can prove the similarity of the two triangles. Okay, so this is all about this lecture. Thank you.